MPLS TE Link Manager. In this video, I'm going to talk about the Link Manager and its usage, and also how we can verify the status of the Link Manager in MPLS traffic engineering. The first question is, what is the Link Manager? And also, what is the usage of the Link Manager? Let me to talk about the Link Manager. After that, we can use some commands for verifying the status of the Link Manager. Okay, what is the Link Manager? The Link Manager is a piece of the Cisco iOS traffic engineering code that does some necessary housekeeping on every TE-enabled router. It mainly does link admission control, and which involves keeping track of the bandwidth reserved by RSVP. Let me to talk about this. Look at here. This is the, for example, our notepad file for this scenario. I am going to talk about the MPLS, okay, TE Link Manager, okay. The first function of the Link Manager is the link admission control. Link admission control, okay. You know that the Link Manager is part of the Cisco iOS TE code, okay, and one of its function is the link admission control for example, controlling about the bandwidth. What is the control of the bandwidth? We are using the link admission control, okay, for keeping for example, track of bandwidth. Let me to give you one example here. Also, maybe we can experience another example. Assume that here we have R1 and then R2 and then R3 and then R4. You know that after the configuring the, for example, R1 tunnel 0, okay, and after the IGP exam finds the path, the best path with the CSPF, IGP can calculate these next hops. Assume that the IP address of the router 2 is 192.168.12.2, and the next hop is 192.168.12.3.3, and finally 192.168.34.4, and then for example, quad 4, okay? These are the next hops that the CSPF, that the IGP after CSPF can give us, okay? You know that we need the RSVP to reserve the bandwidth and also to give us one label for this pass, okay? When we are sending the RSVP from the R1 to the R2, for example, RSVP pass message, okay? You know that in RSVP pass message, we have a field tunnel specification. In tunnel specification, as you saw in the previous video, we have the requirement about the bandwidth, okay, and here we have the requirement of bandwidth 64,000 bytes per second, or this is equal to the for example 512 kilobit per second, okay, and here we can see 64,000 bytes per second. The value is not important. You know that after receiving the pass message, first R2 should examine its bandwidth, its allocable bandwidth on its link, and if the R2 has this amount of bandwidth, can stand by this amount of bandwidth and forwarding the pass message to the next router according to the explicit route object in the pass message. Okay, this is the function of the link manager that, for example, giving admission to reserving this amount of bandwidth. One of the function of the link admission control, or one of the function of the link manager, okay. Also, if we need more than this bandwidth and sending the next pass message, again the link admission control can examine our request, and if we have the bandwidth on that link, it can give us that amount of bandwidth and for example reserve that amount of bandwidth. Because of that, keeping track of bandwidth is one of the important function of the link manager with the link admission control, okay. Let me to review. The Link Manager is a piece of the Cisco iOS traffic engineering code that does some necessary housekeeping on every TE-enabled router, okay? It mainly does link admission control, which involves keeping track of the bandwidth reserved by RSVP on the links and allowing RSVP to reserve more bandwidth on the link for new tunnel, for example, setup request. It is also the piece of software that determines which TE tunnel, okay, LSP can preempt another by looking at the tunnel priorities on the link. You learn about this feature. Let me to write here. You know that we are using the link manager for link admission control. Another usage of the link manager is the, for example, preemption. Let me to talk about this. You learned about the priority, setup priority, and also hold priority in the previous video, preemption. And you know that based on the tunnel priority, we have the option of the preemption on the traffic engineering. Okay, based, let me to write here, based on a tunnel, okay, priority means setup or hold priority. Okay, this is one of the functions, one of the other functions of the link manager that based on the tunnel priority, okay, can give us the preemption. For example, you configure the first tunnel with the setup priority of the 3, okay, or 7, and hold priority of 7, okay, and after that, when we are sending the pass message, here we have the setup priority and hold priority. After that, for the next tunnel, when we are configuring the setup priority and hold priority, for example, with a lower value, means for example 3, you know that this second tunnel can preempt the first tunnel, and this is the function of the link manager that can determine the priorities, and after that can give us the preemption on the link. Because of that, another function of the link manager is the preemption. Okay, after that, it is what triggers the IGP to flood the link state information if the threshold of the links are crossed. I will talk about that, but let me to write here the next function of the link manager, triggering or trigger IGP, okay, to flood a link state, okay, and after that information. Let me to talk about this. This is so important. These three, for example, items are most important functions of the link manager, but maybe link manager should do another function. But for us, it's sufficient to learn about these three objects. The first object, the link admission control, is easy and you understand about the first option, and then preemption, also you learn about this preemption in the previous scenario. Now I'm going to talk about the trigger IGP to flood link state information. First, we need to review the function of the IGPs about the flooding of the link state. Look at here, you know that in traffic engineering, we need the IGPs. You learned about the IGPs and the need of the TE to IGP. Also, you know that we can use the OSPF or ISIS as the IGP, okay, for reasons that we talked about them before. In OSPF, we are sending link state advertisement, and in ISIS, we are sending link state PDUs, okay, you know it. And let me to talk about the mechanism of the refresh in the OSPF and ISIS. You know that OSPF and also ISIS, both of them are incremental, are using the incremental update. Let me to write here, incremental update. What is the incremental update? Let me to talk about that. Assume that R1, okay, before advertise its LSA to the router 2. You know that R1 only needs to send LSA to R2 if R1 experience some change about its LSA. And we don't use the interval updates such as the RIP in the OSPF. Here in OSPF, we are using incremental update. This means that, it means that when we are experiencing some type of, for example, change in the link state, we need to advertise the new link state. Also in ISIS, we have the same condition. Let me to write here, in ISIS, we are using again incremental update. This means that only when the ISIS experience a change about the LSPs needs to advertise the LSP. Also, as you remember from your routing studies, in OSPF and also ISIS, we have one extra mechanism. We call it interval update. This is not a normal interval update, and only this should help to incremental update. Interval update in the for example, OSPF means every 30 minutes by default, OSPF should reflood the link state that previously advertised. This means that if you don't have any change in the link state, every 30 minutes the OSPF should advertise the LSA for ensuring that all of the routers are received the latest, for example, LSP, LSA. Also in the ISIs, we have again the same mechanism, interval, okay, update.